Hey everyone, today we are going to solve a very important array question which is maximum subarray sum. This is a LeetCode 53 problem based out of array, and this question has been asked in a lot of good companies like Google, Amazon, Microsoft, Adobe and so many more. Let's have a look on the problem statement. Here we will be given an integer array nums like this, and from this integer array we have to get the maximum value of sum of any subarray of this array. So maximum sum of any subarray. So here we must be clear that what is a subarray. Subarray is a slice of this array, you can say. Let's say this from -3 to 2, this itself is a subarray. This is also a subarray. If I consider only one element, this will also be called a subarray. And the whole itself is a subarray. It means from index I to j, where I less than equal to j, this is the subarray. And all the elements from I to j will be considered. You should not be confused between subarray or subsequence. Subsequence is something in this direction. Let's say if I am picking first element, third element, fifth element, that is subsequence. And subarray is a contiguous set of elements. So from I to j, where I is less than equal to j, this is a subarray. We have to get the maximum sum from any subarray in it. So how we can do that? If I have a look on the brute force, we can do whatever is asked in the problem statement. They are saying that go to every subarray and get the maximum value of sum. So capture the maximum value of sum in any global variable. And how can you go to every single subarray? Subarray is something which is starting from ith index and going to jth index, where I is less than equal to j. So we can get all the subarrays in two loops, using two loops, for I equal to 0 to n and j equal to I to n. It means firstly we are considering -2 as subarray. Then we are considering -2 1 as subarray. Then -2 1 -3 this subarray. 1 2 3 and 4, this is the fourth subarray, and so on. So what the loop structure will look like. Now using two loops we have captured all the subarrays from I to j. Now we just have to get their sum and compare it to the global sum. How we can do that? If we are writing another loop here, it can go in n cube complexity. N time for this loop, n time for this loop, and n time can be for this loop. N cube time is too much, and we don't have a need to capture the sum in a separate iteration. Instead, we can do that along with this iteration. Let's say current sum is 0, and current sum can be incremented with every single iteration of this loop, like this. And at every step, we can compare this current sum value with the global sum value and update the maximum value in the global sum. So using this method, what can be the time complexity? It is going n square. So you can say it as a optimized brute force approach, but there is a better approach of it solving this kind of problem, which is called cadence algorithm. It is a very standard and highly asked algorithm, and every learner who just gets started with a DSA might encounter this in the initial time of the preparation when he is on the array topic. In the cadence algorithm, we just do greedy like approach. We like whether the currently processed subarray is worth keeping or not. Let's say we are starting from this element, and here if I try to maintain maximum value or answer in a maximum variable, let's initialize it to -2, which is the first element, because first element is also a subarray and its sum is -2, which is a candidate to my answer. If I'm getting the maximum value, I will update it, otherwise it will remain the same. So it is -2. And then if I move further, my current sum is -2, and if I move further, my current sum will remain negative, and whatever is the next value. Let's say current sum is minus 2. Whatever is the next value, which is, let's say, x, minus 2 is always going to decrease the value of x. So there is no need to keep a negative value. So here, this is our main approach. Then whenever we encounter a negative value, we will not keep it, and we will just discard it and make a fresh starting. So let's say we are doing an iteration. We are doing the iteration, and in every iteration, we are capturing the current element. And here we will see whether the current element is better than this maximum captured value so far. If it is better, then we will update the maximum value. This is one step, this is second step, and what can be the third step is, if there can be cases where the temp value is less than 0. In that case, we will just discard the currently calculated temp value, currently calculated current sum. So if I make temp value equal to 0, in the further processing, we will not consider that. So let's say when we are here, the temp value is 1. 1 is better than minus 2, so I will update it to 1. So when we are here, temp value is minus 2, which is not better than maximum. I will not update it, and I will make temp 0. So when I'm coming here, the temp is 0 plus 4, which is 4. 4 is better than current maximum, so I will update the current maximum, and this condition will not run. I will move ahead. Here, the temp value is plus 3. Plus 3 is a positive value which can be used for the further processing, but currently I have the maximum value 4, so I am not updating the maximum value. When I move further, we have 2, which is 4 minus 1 plus 2, which is 5. 5 is better than 4, so I will update the maximum value, which is 5. And if I move further, it is 6. So I will update the temp to temp value is 6, and I will update the maximum value, and this condition will not run. When I encounter minus 5, the overall result will remain 1. So the temp value will become 1. I am not going to update the maximum value, and this condition will not run. When I'm at 4, so 1 plus 4 is 5. So temp value is 5 now. 5 is also not bigger than maximum value. So in this way, in the maximum variable, we have the subarray with the maximum sum. So here, this subarray gave me the maximum value. We started with minus 2, and then I discarded it, and I started with 1, and then I considered it, and I added this. It is a negative overall, discarded it, discarded. 4 is a positive, 4 minus 1, then 4 minus 1 plus 2 plus 1. This is a good positive answer, and this is also positive, this is also positive. But at this stage, I got the maximum value. So this I will return. So here, what is the time complexity? Time complexity is I just did one iteration, and in my iteration, I kept on increasing the temporary value, or you can say current sum. If current sum is bigger than the maximum value, I will update it. And if current sum is going negative, I will just discard it. So these are the three main steps that I have to follow. So ultimately, I just did one iteration, and these some conditions check. So ultimately, it is going to be order of n. Did we take any extra space? No, we have not taken any extra space. So space complexity is order of 1. And this is better than our previous brute force complexity, which is n square. This is called cadence algorithm, which is a DP algorithm on array, and where we do something greedy like approach, like whether the current sum is worth keeping or not. If it is not worth keeping, just discard it. Otherwise, update it. Now let's try to code this approach. Let's write the code for this approach. Here I'm going to do the cadence algo, where we do one iteration, and during that iteration if we decide whether the current processed sum is worth keeping or not. So let's first directly make one loop. I equal to 0, I less than n, I plus plus. What is n here? Int n is equal to nums dot length. N is the length. And let's say this is the answer of this solution for this problem. And here the length is always greater than 1, so there will definitely be one element. So why don't we just take num0 as my max element, because this is also a subarray and a candidate to the answer. Apart from max, I also require a temporary variable where I will just store my current sum. So temporary plus equal to nums I. So this is the sum of current subarray, and if the temp value is greater than max, I will update the max to temp. And there is one more condition, whether we have to keep it or not, worth keeping. If let's say temp is less than 0, if temp value is -2, then there is no need to keep it with us. It will not going to add any value to the further result. So in that case, just make temp equal to 0. So we can make a fresh starting. And in the end, we can return our maximum value. Let's try to run our sample test cases. All the sample test cases are passed. I'm submitting the problem. It got submitted successfully. Okay, hope you understood this question, and this is a very important question asked in a lot of companies.